Section 9.3. Now we're going to use table A3 to find the critical values for the following alpha and alternative hypothesis. So when alpha is 0.05, n is equal to 5, the alternative says it's greater than mu. This is a right-tailed test. Again, anything greater than is right-tailed. Table A3 is based on right-tailed tests. For a two-tailed test, I would have to divide alpha by 2. First, I'm going to find the degrees of freedom, which is n minus 1. So this is 5 minus 1, which is 4. And match up at the top 0.05. So I go find table A3. You can print that out. You still should have a copy of it. And here's 0.5 at the top. And I slide over to the 4. And that gives me that number right there. And that number corresponds to 2.132. Since this is a right-tailed test, that's the answer, 2.132. When alpha is 0.05, n is 15, and now I'm doing less than, this is a left-tailed test, so I have to look up the same way, except when I look up the number, I just want to make it negative. So from table A3, I look up 0.05 at the top. I first have to get my degrees of freedom, so it's n minus 1. 15 minus 1 is 14, so I'm looking up 0.05 and 14. So 0.05 and 14, here's 0.05 still, 14 now is here. So this is my number there, and that corresponds to a negative 1.761. Again, I make it negative because it's left-tailed. When alpha is 0.01 and is a 9, now I'm looking up a two-tailed test because I have a do not equal. The first thing I need to do is take the level of significance and divide it by 2. So 0.01 divided by 2 is 0.005. You don't have to do these for the greater than or the less than. You only have to do it for the not equal. Still have to calculate the degrees of freedom. 9 minus 1 is 8. So now what I'm looking up is 0.005 from the top and an 8. So 0.005 at the top is right here, 0.005, and an 8, which is right here, that number there. So because it's two-tailed, I do plus or minus right here, plus or minus. So plus or minus 3.355. When alpha is 0.05, n is 28, again I'm trying another one of these do not equals. Because it does not equal, it's a plus or minus when I look up the number, but first I have to divide it by 2. So 0.05 divided by 2 is 0.025. Calculate the degrees of freedom. 28 minus 1 is 27. So up at the top I look at 0.025, go down to the 27, and this comes out to plus or minus 2.052. So I'm going to put all the information now together. The mean annual earnings of doctors is $178,258. A random sample of 57 doctors had a mean salary of $192,890 with a standard deviation of about $43,107. Does the data prove that the mean salary of the sample differs from the national average? And they want me to use the level of significance equal to 0.1. First thing I have to do is identify H0 and H1. H0 is always equal, so in this particular case, the mean is going to be equal to 178,258. The next one is the alternative. This is a not equal because I am trying to see if the data suggests that it's different. The sample is different. So different means does not equal. If it was less than, it would say the salary was less than, or it would say the salary is greater than. But this says it's different, so it's a not equal. And it's not equal to, again, the same salary, 178,258. This is a two-tailed test. So first I want to find the critical values. So because it's a two-tailed test, they're telling me to use 0.1. 0.10, I have to take 0.10 divided by 2, and I get 0.05. And again, I divided it by 2 because it's a two-tailed test. I do the degrees of freedom because I need the other number to look it up in the chart. Sample size is 57, so 57 minus 1 is 56. However, 56 is not in the table, so I use the next smallest number, which is 50. So I'm looking up 0.05 and 50, and I get critical values to be minus 1.676 and positive 1.676. Again, whatever I look up, I make them plus or minus for the two-tailed test. Next thing I want to do is compute the test statistic. The test statistic is going to be x bar minus mu divided by s over square root of n. X bar is the $192,890 salary minus $178,258 divided by standard deviation 43,107, and the sample size is 57. So 192,890 minus 178,258 is 14,632. Square root of 57 is 7.55. 43,107 divided by 7.55 is 5709.536. So now we divide 14,632 by 5,709.536, and I get the test statistic to be 2.563. So what I have to do is see if that test statistic falls within the range. So because this is a two-tailed test, I'm at a negative 1.676 for the critical value or a positive 1.676. Again, I have two critical regions, but I'm just focusing on the positive because my test statistic came out positive. So it's right about here. That number is 2.563. This is in the shaded region, so I am rejecting it. That means there is enough evidence to conclude that the sample doctor's salary differs from the national average. Another problem, an economist wants to know if the mean FICO score is less than the average of 720. A random sample of 70 people had a mean score of 705 with a standard deviation of 83. Can the economist conclude that the mean FICO score is less than 720? There's my less than. And use the alpha level of significance equal to 0.05. So first I set up the null hypothesis and alternative. The null hypothesis states that the mean is 720, and the alternative wants to know if it's less than 720. So because it's less than, it's a left-tailed test. First thing I do is find the critical region. I use alpha of 0.05. Degrees of freedom is 70 minus 1, which is 69. Again, 69 is not in the chart, so I use the next lowest number, which is 60. So at 0.05 and 60, I get plus and minus, I get a negative 1.671. I use the negative 1.671 because I always use a negative for left-tailed tests. Then I compute the test statistic, x bar minus mu divided by s over square root of n. So x bar is 705 minus the mean, which is 720, divided by standard deviation is 83. Sample size was 70. Again, I'm not using the degrees of freedom, I'm using the sample size. 705 minus 720 is negative 15. Square root of 70 is 8.376. 83 divided by 8.376 is about 9.92. Negative 15 divided by 9.92 is a negative 1.512. So do you reject the null hypothesis? So again, basically you have your critical region is a negative 1.671. So all of this is the critical region. Here's your number here at a negative 1.512. That is not in the critical region. This is not less than negative 1.671, so no, do not reject. There is not enough evidence to conclude that the mean FICO score is lower than 720.